So hi, I'm Andy Voellmy, Principal Engineer here at Forward Networks, but today I'll be a network operator at Vandelay Industries, managing a network of thousands of devices. So it's Tuesday morning, and 6 days before Christmas, and things are looking good. We solved, my colleague Siva solved, some security issues yesterday in record time, so, life is good. Hopefully it'll be a quiet day at work, and I'll just, catch up on some holiday stuff. And wait, what is that? So I knew things wouldn't be so easy. 6 days before Christmas, and my favorite vendor sends me a little holiday gift. They send me a field notice telling me that a bunch of stuff in my network will break on January 1st, 12 days from now, unless I do exactly what they tell me to do. Yikes. Okay, and by the way, I didn't make this up. This is real. December 20th, this came out. So, and my boss just asked me, are we vulnerable? Tell me if we're affected by this. So I need to actually answer this question. So there goes my quiet Tuesday morning. I have to dive into this and figure out what this is all about. So here's the problem description in the field notice. It says, self-signed certs that were generated on certain devices, certain iOS and iOS XE releases will expire on January 1st. New self-signed certs can't be created January 1st, and any service that relies on these self-signed certs won't work on January 1st. Okay, that doesn't sound very good. So let's see, what kind of services are they actually talking about here? It turns out a lot of stuff, right? SIP, RESTconf, HTTPS server on the device, SSL, VPN, IPsec, the list goes on and on. So this potentially impacts a lot of services. And it would be nice to, if I could just ignore self-signed certs, but that's a can of worms. I'm not sure I can do that. So my goal here is just to find the violations, find the affected devices and the features that use them, and then report them to the security team so people can figure out what workaround to actually use in this case. So are we affected? Well, the first step is to see, are we using some of these affected OS versions? The field notice includes 10 pages of information about versions. So that's 10 pages of stuff. And so, yeah, we're probably affected. Okay, so then that's not enough. So we actually need to, just running that kind of OS version isn't enough. You need to see details about the configuration to see if you're really affected. And that is itself a non-trivial process. It's 4 pages within this field notice just to identify the problem. And basically, at a high level, what you have to do is look for these trust point configurations. Those are essentially certificate authorities defined on the device. And then finding corresponding self-signed certs for that trust point. And then finding these features, any of these many features that might use those trust points. So that turns out to be a fairly complex process. So how am I going to get an answer to this question? Inventory is not really enough, even if it's up to date. I need to actually look at the details to narrow it down to a feasible set of devices. Solving this manually, I could try to log into hundreds or 1,000 devices, and that's just obviously not going to work. I'm not going to get that done in time. Doing this on a single device with a 4-page long procedure is really error prone, so there's no way I'm going to scale that out. So this has to be automated. And that means that I need to develop scripts to, unless I have tools, I need to develop scripts that SSH to these boxes, grab info, config, save all that locally. We're talking about thousands of devices, so that's a lot of data. And then I've got to write scripts to actually go in and analyze that data, parse stuff out of that text. So it's not impossible. It could be done, but I'm not a programmer. I've got a day job here running this network. I don't have time to go develop substantial software tools. So yeah, that's not going to happen in 6 days. So fortunately, my team deployed Forward Networks recently, and Forward Networks has us covered here. So Forward Networks already has this data. It collects this to build the behavioral model of the network. So it already has a configuration, OS version, and all that, and much more. And Network Query Engine exposes that data as a structured, normalized data model. And we actually announced that about a year ago at Tech Field Day Extra. And then Forward Networks then enables me to define custom checks as queries on top of that data directly within that app. And that we announced that a few months ago at Network Field Day 21. And so I should be able to implement this problem, the problem detection logic of this field notice, entirely within the Forward Networks without having to do all the heavy lifting of collecting, parsing, and scripting. So I start diving into Network Query Engine. I see all this normalized data model. I see all kinds of data there, platform information, interfaces, route tables, ARP-MAC, STP, like lots of stuff is there. So that looks good. That's promising. And then the second thing, I see that we've written a whole bunch of checks already. We're verifying spanning tree routes. We're verifying IP address assignments to various interfaces. We're verifying route table consistency. We're doing lots of things, but I'm missing something. For this check, I need access to Cisco-specific configuration. This is about PKI configuration on Cisco iOS and XE devices. So this isn't really the kind of stuff that can be normalized, and it's not in our normalized data model. And that brings us to the newest feature of NQE, which is the ability to use device configurations as a data source within our queries. And the idea is that our devices have lots of configuration commands, and we want to extract certain settings out of this text. For example, maybe we have an IP route command, and we want to pull out the VRF name and the next hop IP. So what NQE allows us to do is to define a command template where certain parts are fixed, like the IP route part, and then other parts are variables, and we can give them names and define the types of those variables. And then when NQE will match these templates against the configuration, and for each match, it pulls out data matching those variables of the pattern into query variables that we can then use within our query to build our logic. And this allows data that's latent in the configuration to be queried just as easily as data from our normalized model. So I'll dive in and show you how this actually works. We'll develop a very small part of the field notice to find devices affected by the field notice. We'll basically follow a three-step process: explore the data model, grab fields that are relevant for this check. We'll construct the check queries for usages of self-signed certs. And we'll basically use 4 constructs in the query. So for each, where, and select are kind of similar to SQL, if you know that. So basically for each iterates over a collection, and where limits your search to specific conditions, and select picks out certain data to show. And then pattern matches is the thing that I just talked about that allows you to extract data from configuration. And then we'll execute it, we'll save it, and it will have this check, will be checked on, we'll verify every new snapshot in our system. So let me switch over here. All right, so just to orient you quickly, so here's the Cisco Field Notice. It's long, but I'll just scroll down to show you the little part of it that we'll implement to give you the flavor of what this is like. So there's a section here called How to Identify Affected Products. And let me make that bigger. And the key parts here is basically this part here. We need to look for these trust points, right? So crypto, PKI trust point, some name. It has to be configured in a specific way. And then we need to look for certificate chains that use that same trust point. It has to be configured in a specific way. And then we need to go look for usages of those trust points. So then we go, and there's lots of usages here. We'll just focus on one, this IP HTTPS server, and we'll look for this one. So we need to make sure that these are using the same trust point, that these appear and they're using the same trust point. So, okay, so here's our network. And I can go into verify and then into the NQE checks tab. And basically here what we do is add a new NQV check. And this is the single environment that lets you build a query. And basically you have an editor on one side where you can write your query. You've got a results pane where if you hit execute, your results will show up there, querying for data. You've got a data model browser here so you can find out what we have. There's documentation and examples. So I actually started a check here. And I just got us started. I just copied over some of the stuff from the field notice here for easy reference. So the first step is to start grabbing, to build our check is to bootstrap from the data model. So we can go into the data model and grab, at least let's start with getting the devices. So we can go here, and next to each part of the data model, it gives you a query that you can use to get started. So you can grab this query, paste it in, hit execute, and there I go. I've got, all the devices printed out here. So that's a good start. So now we can dive in and, okay, let me actually see if I can.
I just have a quick question.
Yeah.
Because I got a little confused right when you dove into this. So are you actually now just on the right side using these queries to start building some sort of script to find pieces of the field notice?
So we're going to implement, we're basically querying the entire network, like the configuration, we'll eventually look at the configuration to look for, to find instances where we've got usages of these trust points. So yeah, it's exactly what we're doing.
Okay.
Yeah, so the results, we'll iterate and eventually right now we're just kind of querying the data and eventually we'll narrow it down to just those devices and usages.
Okay, so you're effectively just building a script on this editor window.
Yeah, that's right. Yeah. So the next part here is to actually start extracting these trust points. And so the way we do that is we use this pattern matching construct. And so when we use pattern matches, it basically returns a list of matches that we can use. So we'll call it, for each TP match in pattern matches. And here I need to, the first argument is basically the configuration lines. So I need to kind of go in here, and I think it hangs off device. Let's see, BGP, HA, files, there we go, files. Information about data sources, config, and state. That looks good. So that's where it is. Config is the list of lines. And now here I put the pattern. And instead of putting this example trust point name, we'll actually replace this with the variable and give it a name. So basically, you don't need to understand every line, every little detail here, but basically this corresponds to, this is the fixed point, this is the fixed stuff in the pattern, and this is that variable element. Okay, and then we'll go ahead and print this out as well. So if we find a trust point, we can actually show it here, trust point, and we'll call it match. So it extracts it into a field called data of the match, where the variable shows up that we defined within the pattern. So we go ahead and execute that, and we find, okay, there's two instances. There's two usages of trust point. Now that's not necessarily a problem yet. Like maybe they don't have a self-signed cert, maybe they don't use the feature, but we're starting to cook now, right? We're making some progress. So the next thing to do is to just do this again and look for, so I'm going to ignore this detail about enrollment self-signed and that in the interest of time, but we'll go on to look for this crypto, the cert chain. So we'll do this again, call this the cert match, and in this case, we'll look for this other pattern. So we'll just quickly do that, put that in there. And now we also, so here we're matching these patterns, but we want to make sure that the trust point names are correlated. They're exactly the same. So that's where the where condition comes in. So we might say where tp match.data.tp name equals cert match, match.data.tp name. Wait a second. So I made some mistakes here, and the editor found it and told me about it. So it guides me and tells me, figures out what variables I should have written. So execute it. Okay, I still got these two devices showing up, so that's good. Making progress. So now we need to look for usages of this. So we'll do exactly the same thing again. This time with this HTTPS, looking for this HTTPS configuration. So we'll call that HTTPS match. Do that again one more time. And this time verify that the trust points of the names are correlated again in this for the HTTPS match. Now we run it, and now we see, okay, that narrowed it down to just that one device. That one device actually has this problem. And so, we can refine this further. So we can take this idea a little further. We can, for example, show the actual line. For example, we can show the line where this trust point is actually used, right? So we can go and now show the usage here. Okay, so that's like the core of the idea of this field notice. And, basically implementing the full field notice is just scaling that up to the, 10 different ways that trust points can be used and doing the version check and so on. But what I was able to do here was, in a very quick time, I was able to, with just a few lines of querying, I'm able to implement this logic. I didn't have to dive into scripting, building, and mostly debugging a whole bunch of scripts. And it's possible because I've got this integrated environment where I can write my query, I can browse the data model, see what's available, bootstrap the query. I've got this editor that finds problems in my code or my query and tells me what's wrong, guides me to the answer, and I can execute and instantly see the results and then iterate on that very quickly.
Are you guys thinking about doing some sort of like an app store for great stuff like this?
That's
That's
a great idea.
Community,
Yeah.
share.
Absolutely.
Like a Git repository?
Yeah. Hey, maybe you should come. So that's a great segue. All right, so it took some work, but it wasn't too bad, right? I built my check in an afternoon. I've got an answer to my question, right? I know exactly which features on which devices are affected by the field notice. And, I've got a bonus here. Like, I just built something that completely automates this problem detection. I could give this to somebody else, and they wouldn't even have to read the field notice to use it, right? So I can go ahead, I can post it on the NQV GitHub repo where we can all share these nuggets, and then we can go make some noise about it online. And we did this, and some of our customers actually used this. So Tuesday turned out to be a good day after all.